Hello and welcome to this session on data normalization. In this session, we'll explore what data normalization is, why it matters, and how it improves data processing and machine learning. Let's get started. Data normalization is a crucial step in data preprocessing. It ensures that different datasets follow the same scale, format, and structure. This makes it easier to compare data from multiple sources and improves the accuracy of data analysis. By structuring data consistently, we make it simpler to interpret and faster for machine learning models to process. Now let's talk about different types of normalization techniques. The first one is min-max scaling. This technique transforms data to fit within a specific range, usually between 0 and 1. Next, we have z-score normalization, which standardizes data by subtracting the mean and dividing by the standard deviation. Another technique is decimal scaling, which shifts the decimal point of values, making large numbers more manageable. Each of these methods ensures that data is consistent, comparable, and ready for analysis. Let's take a closer look at min-max scaling. This technique adjusts values within a dataset to fit within a specific range, usually from 0 to 1. It works by subtracting the minimum value from each data point and then dividing by the range of values. This method is widely used in machine learning to improve model performance and prevent features with large values from dominating smaller ones. Now, let's explore z-score normalization. Z-score normalization transforms data so that it has a mean of 0 and a standard deviation of 1. This makes it easier to compare values from different datasets, even if they have different scales. It is especially useful for detecting outliers, as values far from the mean will have extreme z-scores. This method is commonly used in statistical analysis and machine learning models. Next, let's discuss decimal scaling. This technique normalizes data by shifting the decimal point based on the maximum absolute value in the dataset. It is particularly useful when dealing with very large numbers, such as financial data or scientific measurements. By adjusting decimal places, we ensure that all values are within a manageable scale while maintaining the relationships between them. To understand how min-max scaling works, let's look at an example. Imagine we have the values 10, 20, and 30, where 10 is the minimum and 30 is the maximum. Using the formula x scaled x 10 and 30 so 10, we get the transformed values 0, 0.5 and 1. As you can see, the scaled values now lie between 0 and 1, making them easier to compare. Now, let's look at how normalization is used in real-world scenarios. In finance, it helps in comparing stock prices from different companies. In healthcare, it ensures that medical data like blood pressure readings are standardized. In machine learning, it improves model training efficiency and accuracy by preventing larger numbers from dominating smaller ones. Choosing the right normalization technique ensures better insights and reliable results. Let's summarize what we've learned. Min-max. Normalization scales data to a fixed range between 0 and 1. Z-score normalization standardizes data based on mean and standard deviation. Decimal scaling adjusts the decimal point to handle large numbers effectively. Choosing the right normalization technique depends on data distribution and business needs. Before we wrap up, let's discuss some key recommendations. Always understand the dataset and its distribution before choosing a method. Use min-max scaling when data needs to fit a specific range. Apply z-score normalization when comparing datasets with different scales. Use decimal scaling when working with large numerical values. Mastering these techniques will improve data pre-processing and model performance in real-world applications. That brings us to the end of this session on data normalization. We hope you now understand why normalization is essential and how different techniques work. Thanks for watching and see you in the next session.